Welcome back. So, last time we met, I was showing you all how to set this it's basically a graphics demo. How to make a scene that looks 3D while actually not, of these balloons just kind of rising out of the water. You can see the reflections of the balloons in the water. You can see the ripples as the balloons rise up. I think I made a couple changes since we talked. Set a set the max number of balloons on the screen to 15, just to make sure the system doesn't get too overwhelmed. That max number can be played with. I'm not exactly sure what a good max is here, and it might depend on your computer too. But today, I wanted to see if we can put this balloon scene to music, turn it into sort of a music visualizer. Now the idea is going to have, let's see, I have a plan in mind. I've already worked out the plan. We're going to be picking on Pachelbel's Canon. It's I don't know. It's a song I really like. It's been around for hundreds of years. I'm not exactly sure when it came out, but I'm going to be playing the song in three layers: a bass layer, a middle layer, and I don't know, bass clef, treble clef, and I guess really high notes on the treble clef. With octaves 3, 4, and 5. I think it's 3, 4, 5. Might be 4, 5, and 6. We'll get into it in just a minute. I think that we're going to want the high notes popping up in the very front. Basically, the Y value is going to be determined by the frequency of the note, and we're going to have to scale it somehow. That's the important thing. And I think the color and the X value will continue to be random for now. I might change my mind later. So let's get into it. I want to explain my thought process. So, Pachelbel's Canon in D. You might have heard it at a wedding if you've been to a wedding recently. Da, 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 do, do, do. Sorry, that might be a audible rendition. You don't expect to hear singing from your local computer programmer. But I have a file here that I've already created, the Canon miniscript file. I'm gonna break this down into sections so that I can demonstrate what it's doing. So let's go back to the wiki. That'll be a good place to start explaining this. So note frequencies. You can see we have a value table here on there's a description of the note fric or note frequency. That function, you feed it a number for the note, it outputs the frequency of that note. And note numbers start from 0, which is octave -1, which I don't think you'll find that on the piano, but mathematically it exists. Middle C is C4, which is way up here. So basically an octave has 12 notes, going from C, C sharp, all the way up to B. And then like, the next C is note 12, which is outside of that octave. So we're going to make some functions to encapsulate this. You can see that we have all of our notes. C starts at 0, it's the first note of the octave, all the way up to B, which is 11. But we also need to calculate the base value for that octave. The octave size is 12. We feed it the octave number. It's octave plus 1 times octave size. That was confusing me for a little bit, but basically, note number 0 is an octave -1. So we need to take the -1, add 1 to it to get 0, multiply it by 12, so 0 times 12 is 0, and that feeds us note number 0. If we're in octave 0, then we want the octave number times 12 to equal 12, so that's 1 times 12 is 12. So it's like 0 plus 1 will feed us the base note. 0 plus 1 times 12 will feed us the base note for the octave. So basically, let's see, I'm going to comment out some of this. I want to be able to demonstrate what's going on a little better. Now, before I start mangling this, let's back it up. Okay, we're going to ignore the chords for now. We're going to ignore the chord player and the half note player. We're going to ignore the play chord and play half note functions. Going to ignore a little song. Basically, we're going to ignore the entire rest of the program and just focus on playing notes, single notes. Every song, if you look at sheet music, has like beats per minute. Like right here, that little, you can see oh, open image, a new tab. There you are. Beat that quarter note equals 100. Beats per minute is 100. The quarter note represents a single beat. The mini macro works in seconds, so we have to convert beats per minute to basically seconds per beat. So there's our beats per minute set to 103. We'll change it to 100. Beats per second is the beats per minute divided by 60 seconds in a minute. To inverting that from beats per second to seconds per beat, we do 1 over beats per second. So this is the value that will be controlling the, like, wow, when we move to the next note. And so we also are calculating durations. Basically, a quarter note is, I'm calling it dir4, duration 4, because normally there's like 4, if you're like, this is like 4 time, 4 beats per measure, basically. And so seconds per beat, the 4 represents a quarter note, and it's equal to the seconds per beat. Duration 8, that's an eighth note, so that's half of a beat. Duration 2 is half note, that's like twice as long as a quarter note, and the whole note is 4 times as long as the quarter note. So durations all over different notes. And then we are constructing an instrument. I like the triangle waveform. It actually sounds a lot like the 8-bit Nintendo that I seem to keep talking about, which you'll see in just a second. Especially when you get up to octave 5, I think it was. The volume envelope, when you're, let's see, I'm gonna draw a picture. As soon as that loads. So you gotta think about it. If you're playing notes, volume envelope like that, if you just play a note and then stop, you're going to hear like a triangle wave, gonna go like this, and then your note will end halfway through a triangle, which means you'll hear a clickety sound at the end of your note, which just kind of sounds bad. Make a volume envelope that kind of goes down to 0 at the end of the note, means that just like it'll be a full triangle wave, and then at the end, the triangle will just get smaller and smaller and fade out. So you won't hear the sharp click at the end of the note. I'll try to demonstrate that for you in just a minute. Let's initialize. Let's go ahead and demonstrate that now. Volume envelope, leave that set to 1. And we have our play note function, which takes the octave number, the name of the note, and the duration in seconds, calculating the base note number based off of the octave. So C4 will be 60. So middle C, C equals C4. So basically what it's doing is 4 plus 1 times 12, which is 5 times 12, which is 60. And if we go back to the wiki, you'll see that C4 is 60. So that's how we get there. Playing a note, we calculate the base note, we get the note number from the base note number, plus we look into our notes map. The note name is C, go up to your notes map, C is 0, looks that up, adds it to our base note number, so note number becomes 60. Get the frequency for that note number, plug that into the note player, plug in the duration, play the note. Let's test it. Make sure that's all commented out good. We're just going to play a note. Play note. Octave 4. The note is C. The duration is equal to a quarter note. There you go. C4. Let's play a whole note. Half note. So it's a little bit longer. And a whole note. And then if you want to go to octave 5, it's still C, but it's a higher note. Octave 3, and so on and so forth. Now the problem, I was talking to you about the volume envelope, which on our note on our sound right now, that volume envelope is just 1 all the way across. So we're going to test this out. We're going to just play the scale. The scale starts with a C. Series of notes, or note in notes, play note, octave 4, note, 4 quarter notes, and 4. Listen carefully. Hopefully this will be a good demonstration. Well, that was not a good demonstration at all. Okay, what did I miss? Stick this in one line. Note and notes. Oh, come on, you. Oh, right. It's playing all the notes at once, so what it's doing is that that same instrument is told to play a C, and then immediately told to play a D, and all the way up to B. So basically, it's only capturing the B. Like that. That's why we're only hearing the one note. To write a good demonstration, we actually need to do this a little bit different. We're going to go back to the code editor. This is a little bit more involved, but it's not bad. C, D, E, F, G, A, B. Index less than notes length. We're going to iterate through all the notes, and we're going to capture the time. Last note time is 0. If time minus last note time is greater than or equal to the duration of a quarter note, then we move to the next index in our array. So play the first note, 4, play that first one, 4. Actually, I'm gonna get the next note time for a reason we'll see in just a minute. next note time equals time plus duration 4. So we're going to wait for the length of a quarter note before playing the next note. So if time is greater than equal to next note time, we move on to the next note, and then play note, octave 4, grab the note, duration 4, and then calculate the next note time. Time plus the duration of the next quarter note. I think that will play the scale in octave 4. Rerun. 7 out of range. I actually wasn't expecting an out of range error. Oh, it's because when it gets to, it plays the B and then waits again because it's still less than the note length. Moves to the next index, which is out here, past the end of the array, and it tries to grab it and dies. And you can actually just fix that by moving that down there, and then you won't need that anymore. Next note time is 0, because we wanted to immediately play note at index 0, and here we go. So, if you listen carefully, you'll hear it. Da 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 da. Just a little bit of a click at the end of each note, which just doesn't sound good. So we're gonna take a volume envelope and stick it here. Let's go from 1 to 0. Going back to our picture. Going immediately from 1 to 0, let's say this is 1 and that's 0 along our graph. And going from 1 to... Oh, that's a horrible picture. So we have our coordinate plane. 0... Oh, I still don't like that, sorry. No coordinate plane. 0, comma 0. X goes from 0 to 1. Y goes from 0 to 1. Having a volume envelope of 1 to 0, we'll tell it to do this. Like straight diagonal line, 45 degrees all the way down. However, it might not be 45 degrees, but it goes straight down. Let's see what that sounds like. So it hits the note hard and then immediately begins fading. And then you can just keep adding ones until... See, it's doesn't fade quite as quickly. And in my case, I have 8 of those. You know, now that I'm listening to it, I don't like how hard it's hitting at the beginning. Let's change that to a 0. So that it'll fade in and then fade back out. Kinda like that. It's more woodwindy. Just a little bit of a click, but no, you can't have it all. You can actually do some weird stuff with this. Let's say that stuck another 0 there in the middle. And it doesn't have to be 0 and 1. You can stick any number you want in there. You can just get some weird effects, and you can modify the waveform in the same way, but I'm not getting into that. We are going to stick with that waveform, that volume envelope. There you go. So that's how you construct an instrument. That's how you play the scale. But we're not wanting to only play notes, we're wanting to play chords. And this is where it got really fun. So I found this link to be really useful. So basically, you're entering the name of the chord. Let's say you want this. It's an A major chord, and it will tell you the notes in the chord. I know enough music to know that there should be 3 notes in the chord. I can plot out some of them based off half steps and whole steps, but I don't have them all memorized. Being able to look it up was really nice. And we have to know the notes in the chords because going back to Pachelbel's Canon, chord inversions. Let's see if I can find Pachelbel's Canon is based off of chord progression. And this is basically it. D major, A major, B minor, F sharp minor, G major, D major, G major, A major. Take those chords and made an array, which you will see down here. So the song we're playing is going to be based off of, you have an octave, you have the name of the chord, and we have the duration that we're playing that chord. Each one is a whole note played for the entire measure. And so we need to get each of those chords and break it down into its individual notes. The way I did that, created this chords map. It's a map, not an array, because I'm going to map the name of the chord to the notes in the chord. I took each of the chords in that chord progression back to this site, broke it down into its individual notes. Like A major is A, C sharp, E, and there you go. And I did that for each chord. If it, like the little M is minor, if it's not minor, then it's major. That's the rule. And then with that, you just you can plot out each of those chords. But let's demonstrate the chord player for just a minute. We don't need this anymore. Let's turn our chord instrument back on. Basically, you have to have a separate sound object for each sound you want playing simultaneously. You can't just reuse the same sound. We have a chord player. The chord player is an array of 3 elements because there's 3 notes in the chord. Range 0 to 2, which actually goes from, yeah, it's inclusive. So it includes the 0 and the 2. So in will go from 0, 1, and 2. We'll get 3 elements. For each element, we'll create a new sound. We're going to start with our base value envelope and multiply it by 0.5 so that the chord player will be a little quieter than the base volume. And we're using the same waveform. The waveform is like the base sound of the core sound of the instrument. And then, now that we have our array of chord players, three different sounds, we create the play chord function. Give it the octave. Instead of a note name, you have a chord name and the duration of the chord. So based off the chord name, we pull the chord out of our chords map, calculate the base note number from the octave, just like with the note player. And then for each one, we're iterating through the elements of the chord, grab the note name, convert that into a note number, play it, just like with the note player. So let's demonstrate that right quick. Run it so that we get the function back into scope. So let's play a chord. Octave 4, A major, duration 1 for a whole note. And there you go. Do I have a C? I do. Oh, I don't have F sharp major, only F sharp minor. So yeah, this is tons of fun. It's just it's fun getting it to play something that actually sounds good. So now that we are able to play chords and we have our chord progression, we can start playing around with playing the chord progression from Pachelbel's Canon. So we're only going to go with the next chord time, I think. We're not going to play the half notes or whole notes yet. Half notes or quarter notes. Dealing with those bits yet. So this is the same thing we were doing with the note player. Next chord time is set to 0. Well, set to time, which is essentially the same thing. We're wanting it to immediately play whatever chord comes next. We're pulling the next chord, the next element out of the song array. So we have to have our song index. So we're grabbing the details of the next element we're playing, the octave, chord name, and duration. Here, let me split this so that it's easier to see. So song at song index will give us this array of 3 elements with the octave, chord name, and duration. Pulling out those 3 elements, play that chord, and then calculate the time for playing the next chord. And then we tell the song's index to move to the next element. This was something else I was playing with, but basically if you use this bit, then it'll walk back and forth across your song array randomly, which I ultimately didn't like the way that sounded for the bass notes. So we're going to leave this as 1. And then if the song index is greater than the length of the array, greater than or equal to, we're going to wrap back around to 0 and tell it we've moved on to the next iteration of the song. And not dealing with that yet. Is done should always be true. Well, always be false, because we just want it to play forever right now. And let's test it. It broke because I forgot to define iteration, but otherwise it would just keep playing that over and over again, which is perfect for us. So now we have our bass notes. Let's add in our half notes, half the size of a whole note. The whole half note player looks just like the quarter note player. But basically we're playing the half notes at full volume, chords at half volume, and quarter notes at a quarter volume. It's because when you get into the higher frequencies, it actually sounds louder based off of the same volume envelope. So you just gotta tell it to back off. And you can see here the play half note and play note are basically the same function, but referring to different instruments when they're playing. Turn on next half time, half index. Then we have this block here. I'm going to disable the iteration check for now. So if it's time for the next half note, we're going to look at the same element that we're playing for the chord, but we're going up an octave from wherever that was. And grabbing the same chord name, duration. Chord name, grabbing the chord, which is something different from down here, and the duration. And then we gotta grab one note out of that chord, which is where the half index comes in. Half index is set to 0 and will walk randomly between 0, 0, 1, 2, 0, 1, 2, 1, 0, 1, 0, 1, 2. It'll just kind of walk back and forth, meandering over the chord, whatever chord is active. And then plays that half note, calculates the time for the next half note. And let me show you what that sounds like. Assuming I uncommented everything I should have. There you go. Kind of doing a little bit of programmatic improv. Okay, break that for a moment. So we're not done. We are going to disable it for a bit though, because we're also going to be plugging in quarter notes. And basically the quarter note player works just like the half note player. Disable the iteration counter for the moment. But it's the same way as the half note player, except it's going to be meandering over the chord twice as fast as the half note player, and it's going to be one octave even higher than the half notes. So it's like if whole notes are octave 4, half notes are octave 5, quarter notes are octave 6. And let me show you what that sounds like. So it walks a little bit faster. All right, break, Control C. Now, let's put it all together. So we have 3 sections of notes, and we can play all 3 simultaneously, but what I'm going to do is turn these iteration timers back on. So what this will do, whole notes will be playing continuously. If the iteration mod 3 is like every 3 iterations, it'll be playing half notes. Every 5 iterations, iteration mod 5, it'll add in the quarter notes. So normally you'll only hear the bass notes along with either half or quarter notes. But if you're at an iteration that is a multiple of 3 and 5, then you'll hear all 3 layers simultaneously. And we're going to turn our timer back on. Play forever is false. And we're going to turn on our countdown. We're gonna play this. Let's keep it at 60 seconds for now. And iteration plus 13, so we can just get a ways into it. And basically, if we're calculating the end time as the current time plus the total duration in seconds. So basically, time has to get to the end time, and it's not playing forever. Then we're going to set is done to true. But it's only going to do that check at the end of an iteration. So we're going to get to the end of our playtime. It's going to finish the iteration it's on, then it'll stop. Because you don't want to break it in the middle of iteration. It'll just sound funny. So let's demonstrate. I'm going to play it for 1 minute. it's going negative now because it's going to finish the iteration it's on before it stops. And I heard it sounded a little crackly when it got to the top there. I think the problem is that the volume level is saturating. I think that's the term. You don't want the volume to go over 100%. Chords are at 0.5. Quarter note. All right. Yeah, chords are 0.5. Oh, no, that should have been 0.5 plus 0.25 is 0.75, which should have still worked. We're going to cut all of these in half. And I'm going to run one more test. I feel like that sounded a lot better. I'm not hearing that same cracking from the speakers anymore. That actually makes me really happy. I could probably run this program all day. Might drive my family nuts, though. Okay, so we have our song, and now, let's see. The source code for this, we don't need the copy anymore. Source code for this is going to be up in the Ripples repository that I posted previously. And see at the top, we're just going to call this one Pachelbel's Loose Canon. Hopefully that hasn't been copyrighted. Now for the next part, which I have not pre-scripted, we're going to try to integrate that song into our balloon animation, which we have on the left here. And let's see, how do we want to do this? Let's start by just importing the file. That'll give us access to all the variables and things from variables and functions that we've already defined here. And we're going to do a trick here that I learned from reading the library code. We're gonna put all that inside a main function. If locals equals globals, then run the main function. So if you're running this independently, it will just run the main function and you'll get to hear the song. If you are loading it in as a library, locals will not equal globals and it will not run the main function. Let's make sure I'm right. Run main. No music. Okay, that's good for the moment. Now we have to integrate our song into our event loop. Getting all this code out of the way. Collapse, collapse, collapse. We're going to pick on the onUpdate function, I think. There's a couple ways to do this. It's like we can use the do after. We can have like 3 do after timers for our half notes, quarter notes, and whole notes. But it's not entirely clear how to integrate that because of the iteration counter. I think what we're going to do is just put everything in the onUpdate. First of all, we're going to tell it to play forever. And then we're going to turn off the random balloons. And we're going to turn off the onClick function. If you want to, you can download the source code, turn that back on, whatever you want to do. I'm open sourcing all of this. And we're going to plop all of this before I finish saying we're going to refactor this a little bit. I want this in three functions. We're going to have play whole note, no, play chord equals function, play half note, play quarter note. Then play. In this one, it's like we're playing quarter notes at the top, and then half notes, and then chords. The order is important because of the way those counters are running. Let's see. We're gonna start. Oh, do not cut. We're copying. Do not want to break our little demo program. Half notes. Just realized I dumped some of this in the wrong spot. That's play chord. This is play quarter note. And now we need to make sure this is referring to correct namespace for its variables. Note name, time, next note time. This is the part where I often forget something. you know, the mini macro will tell us if we forgot something because it'll throw up a handy little error message saying that the variable's not defined. One of the things that helps with being a computer programmer is being a bit obsessively detail-oriented. And we're actually not using this anymore. We're seeing it in the event loop, so there is no is-done flag. We need these bits or those bits. Check the work briefly. I think I got it all. That should be enough for it to begin playing the music as part of our event loop, which is half of the problem. Let's see if it works. An identifier. Where's play quarter? Play quarter. Oh, it's called play quarter note. Play quarter. That. There you go. It's playing the song in the event loop, but it's not actually tied to the balloons anymore. Why did those balloons pop up like that? Okay, first of all, coming back here, setting iteration to 0. We want to start at the beginning. Set first iteration. So if we set no, if we set it to 0, iteration mod 5 is 0. No, we actually do want it to start at 1. Oh, that did nothing. Weird. I don't hear anything. Do you hear anything? No, I didn't think so. All right, what are we doing wrong? Weird is I thought it was just working. Wonder. Wonder. Reset. Now it works. Rerun it, doesn't work. Okay, something's not being reset properly. Set iteration back to 1. It's probably the ensure imports. But the cheapest way to clean up. End your program, do a reset. Then when you rerun it, there you go. Right. What we want to have happen, whichever notes I think that basically, if the chords are the only things playing, we're gonna launch balloons based off of chords. Half notes are playing, we're gonna do that. We're gonna let the half notes control launching balloons. If quarter notes are playing, we'll let the quarter notes control launching the balloons, but we'll only allow one group to control the launching of balloons. Okay, that's the plan. So let's start with chords. And I'm going to invert this because it'll make it easier to read. Easier for me to read. I'll do that to all three of them. No. Problems with like the things like the no. No, I'm sorry. I'm not doing that. It's not broke, don't fix it. So in the chords, we're wanting to launch a balloon. Generate balloon, and it takes the X, Y, and color parameters. X is going to be a random value equal to the width of the screen. The Y is more complicated. We want to take the frequency of the current note. Of course, it's a chord. Which one do you pick on? Let's pick on the middle note. Frequency is the chord name. Chords, chord name. Grab the second note of the chord. And referring back to this, if you have the name of the note, you do this to get the frequency. Well, you know, the note number might actually be more useful. So notes, convert the note name into a note number, hit the base note number, and now we have the full note number. And we need to scale that somehow. We're working over 3 octaves, with the bass octave being controlled by this. What that means is bass octave equals 4. We're going to parameterize this. Just a moment. Please hold while your program is parameterized. So we have our bass octave. High octave equals bass octave plus 2. Lowest note number equals bass note per octave, beat it to bass octave. Highest note number equals, start the bass note per octave, hit the high octave, plus notes. The highest note is a B, I think. Yeah, it's a B, because there's no B sharp. B sharp is C. So we have our lowest note and our highest note. The lowest notes will be at the bottom of the screen. The highest notes will be at the top of the screen. Now, there's the highest notes. The problem is any notes that appear at the top of the screen, those balloons are going to be tiny and going to take forever to fly up to the end of the screen. So we want less of those to generate. Base notes will be at the back. We'll see what that looks like. We're able to get a note number. We need to convert that to a y value. Min y is 0. Max y is equal to our water height. So basically, Canon. Oh, let me think. Math. Lowest note number, highest note number. The length between the two notes is this. And then we have our note number minus the lowest note number divided by note length should give us the percentage distance into that range. There, we can calculate the y, water height. That'll put high notes near the very back, I think, because as the note number goes up, the y value will go up. This, and then the color can remain null, will generate random colors. That's fine. Not only be for chords. Let's see what that looks like. Base note for octave is undefined because it's in the Canon namespace. That's still not going to work. But it sounds nice. This note number is unknown. Getting there. Oh, reset. There. So I'm liking this. We're going to do the same type of thing in the other two functions where they're playing notes, but we need to turn that into its own function. Nope. Got the octave. Y equals calculate Y for note, octave, note name. Let's make sure that still works. Nice. Okay. Now, the next trick It should only play. It should only generate notes. It should only generate balloons on chords if neither of these is taking precedence. So if that doesn't equal 0 and that doesn't equal 0, then you are allowed to generate a balloon. And then for half notes, if the quarter notes aren't taking precedence, it can generate a balloon. For quarter notes, if quarter notes are playing, they can always generate balloons. Is that right? It might be right. It's going to be interesting to see what happens to the performance when the screen fills up. Right now, the max balloons is 15. So if there's 15 balloons on the screen, it doesn't matter what's happening in the song, it's going to stop making balloons until some of them go away. Let's see what that looks like. We're going to run this for a while, maybe a couple minutes. So I'm going to set a timer on my end. I'm setting on my phone so you won't see the timer. And we're going to let this run for a bit. Aww, I'm not seeing any more balloons. The half note balloons aren't popping up. Okay. Okay. We're really close though. So the problem is iteration mod 3 will always be 0 in here. We make sure iteration mod 5 doesn't equal 0. Because we want to make sure that the quarter notes aren't taking precedence when we're doing this. Okay. From the top. Oh! X is unknown! Oh no! Is it line 320? Yeah, okay. My bad. So the problem is this. You actually need the X and the Y to know where to put it. Oh. Problem is when it breaks like that due to an error, it doesn't do the reset at the end, which is not means all our variables aren't being reset like they should be. And, I want to know what it looks like if we generated a balloon for each of our chords. Our note name in Canon chords chord name. Generate 3 times as many balloons as long as the chords take precedence. Chords, chord name. That. It's actually note number. Okay, we're going to refactor this up just a little bit. We're really close. We'll pass the note name into the calculate Y for note. Octave note name. This converts the name into a number. So that will launch a balloon for each of the 3 notes in the chord. Should. Move this to the top. Then there's another error in play half note, generating the balloon. The note name is already required. It's up here. We'll make sure we generate a balloon for that note. Same thing with the quarter notes. We already know the note name, we're not recalculating. All right, let's let this play for a bit and see how it works. Reset, run. Oh, 360. Little error. Keep making that same mistake. It's weird. Anyway. See, it generated 15 balloons really quickly, and then it stopped. And now we can generate more balloons as some of those 15 fall off the screen. The problem is, I don't like making that many balloons all at once. So we're going to pick a random note from that chord. Random number times 3, floor that to get 0 through 2, grab the note, that random note out of the chord, and that will be what we do for picking the note. And rerun. Now let's just watch it for a bit and see if it works. Half notes should be popping in any second now. So balloons are now popping up for half notes, but not chords. Gonna fill the screen twice as fast. So we're going to reach our 15 balloon limit, and it's going to pause. Going back to chord balloons. There we go. Now the quarter notes are taking precedence. Quickly fill up the screen, and then it stops. Some of the balloons are pretty far out. You can see there's a tiny little yellow one around the center of the screen there. That's going to take a while to get out of the way. Maybe that's just okay. I could make the farther out balloons faster, but I don't think I really want to. If you want to, grab the source code. It's not that hard to change. It's looking really good. Just makes me immensely happy. Kind of curious to see what happens when all three layers are playing simultaneously. Quarter notes should take precedence. It should just work. So I think we're going to call this one done. All the source code is going up to the same itch.io repository project as the balloon demo, the Ripples repository. You will have to download it to see this. The web browser just couldn't give me enough performance to run all of this simultaneously. But I think I'm going to record another video of just like letting this play for an hour. Maybe my daughter will like it. Maybe you'll like it. Maybe I'll just enjoy it for myself. I don't know. I don't know about you, but I could probably listen to this all day. There it is. All three layers. And that's it. I'm going to stop the video there. Hope you enjoyed the concert. And that's it for this set of videos on this demo. Gonna be picking up the RPG Light game again next time. And hope you're able to join me. See you later.